So we've just left the ramp on our first test drive, where our main aim here is to look to make sure the lambda meets the aim and that our knock channels are all, the individual cylinder knock channels are relatively even, nothing crazy going on with any of them, and that they're not exceeding the threshold. We're going to test to 3,500. There's no chance of there being knock up to that level. So if the channels do rise above the threshold, then we need to adjust the threshold to suit. So they're our key parameters to watch. Now the best screen to do that on is the knock screen. So if you go to favorites and then open them up, there's three choices there. You'll find one for knock. If you click on that, you'll see the knock parameters turn up. Then we go to the right there, we can see the main scrolling data, the channels. If we click in there and then press F6, then we get that full screen. Up the top we have our engine speed, throttle position, our lambda and lambda aim, fuel mixture aim. And then down the bottom of those channels we see the knock threshold and the 8 individual knock levels. All right, so provided nothing silly goes on with that data or those channels, then we just proceed up every 500 RPM, and at this point we'll go to 4,000 and then have a look. All right, off we go. Probably jump the gun a bit there, so we probably go to, we're at 1,500. I'll drop back to 1,000 to get that data. At this level, there's no way the knock's going to give you any issues, so this is more about just checking the efficiency map. The lambda meets the aim, of course, because the closed loop's on, but later we're going to go back and look and see how much closed loop it was using, and then we'll zero that out. All right, so we had 1,500, we'll go to 2,000. Move the throttle slowly, so we're not invoking any transient response in the ECU. So we're just nice and smooth on the throttle. We're getting lots of data there at 2,000, next to 2.5. Everything good, Ben? Good. Plenty there at 2.5. 3,000 next. There we go, 3 grand. It's our 3.5. 4,000, finally on plane. That's plenty of data there now. We'll head back to base and have a look, make our corrections, and then come out again. Okay, we're back at base. We've got I2 Standard open and we're going to look at the data. In I2 Standard, we've got some worksheets across the top, and on each worksheet there are channels there that you can look at to help you assess what's going on. We've got health, tune, knock, gear and idle, and a couple of pressure channels. Right now we're just going to look at tune and knock, and let's start here. Alright, so engine speed, throttle position, and manifold pressure. You can see we've got our exhaust lambda, which is the orange channel here, and then our fuel mixture aim. So that's the target, and then the orange is the lambda. So we should always be on the target if the closed loop's working. If it's not on the target, then maybe it's at the edge of the trim for the closed loop. And right where I am now, you can see it's by the dead straight line on the closed loop here. It's at the trim limit of -5. Now that's actually adjustable, but we try and keep that, get the tune as good as you can and keep those trim limits tight. It can save a lot of lambda oscillations on transients. So. All right, and the last channel at the bottom is fuel pressure. We know from testing that the fuel pressure or the fuel system module on these Mercuries is marginal once you start doing supercharger mods and putting MoTeC on. So we're always keeping an eye on the fuel pressure to make sure that it's not dropping, because there's no point in tuning against a fuel pressure that's fallen. All right, so the idea here is we're going to look and correct the errors that the error that the closed loop is fixing. The best way to do that, if you haven't got the tune-up still open on your laptop, and sometimes you're doing this the next day, you can go into Tools and View Device Config. All right, here it will take the tune-up or the configuration out of the log file and bring it up for us to look at. And we're going to use 1.5, and here it comes. So this is the actual tune-up that produced that log file. All right, click that screen back on so we can see what's going on. And here's the efficiency map. All right, so now we'll Alt-Tab back to our i2 screen. And what we want to do is progress through the test here, looking at each engine speed and load or manifold pressure, and having a look and seeing if we want to do a correction. So you'll recall we started a little bit fast and we came down to 1,000 here, and so we'll have a look at this particular spot. So let me just scroll. You can scroll back out with a mouse or press F2. There's the full data. If you want to zoom in on a point, you can either click there. I can roll in on the mouse. I can, use up arrow and down arrow. There's lots of different ways you can do that. If you go to Help up here, you'll see Help Topics, and in there you'll be able to see all the shortcuts and the way you can manipulate the software to do what you need. All right, so here's our first point we're going to look at, 1,000 RPM, and our manifold pressure is touch under 50 kPa, so we'll be going for that site. 1,000 RPM, 50 kPa. Our lambda is on our target, but we've got a 9% trim pulling that out, and that's probably a little bit more than I'd like. We're sort of hoping for somewhere either right on 0 or 1 or 2% negative. You want to just be a little bit pulling fuel out, so that if you ever lose the closed loop because the lambda sensor has a problem, then it might just be 1 or 2% rich. So we can Alt-Tab. We've got our position here, 1,000 RPM and 9% too rich, isn't it? It's pulling out 9% on the trim. So we go to that same site here, 1,000 RPM, 50 kPa, and what we're going to do here, there's a couple of ways you can do this. We can go L for lambda was, and we can type in what the lambda was and the fuel mixture aim. All right, so that's one method. We can kind of guess the number if we're experienced, or we can apply maths to it. So I want to pull out, let's say 6%. So I'm going to go times 0.94, and that'll pull out 6%. That still leaves me a little bit of just be slightly on the richer side, so there'll be a little bit of trim coming out on the next test. All right, so there's our spot. You'll see that that's got a diamond there, which means we've made a change there. Now if you want to, we call backspace, we want to mark that properly so it stays with a mark to say you've tuned that. We push backspace and see there's a little black square there now. So what we're saying there is that's a good site that we've looked at, we've made a decision on, and we've altered it and we're happy with it. All right, so now it's just a matter of going through the data, going to each intersection point. So that's each column by row intersection point, and then making a change. And once that's done, we'll review those changes and we'll probably smooth some cells around there to that makes sense to have a nice even flow on the efficiency table. All right, so that's our 1,000 point, and we're sort of looking for 1,500. Let's go back here. Here's our 1,500. All right, so we got 5% out there. Not really worth worrying too much about, but we'll have a little bit of look. So that's 1,500 and just under 60 kPa. So 1,500, we go up to here, 1,500, 60 kPa. So let's go times 0.97. All right, and backspace. All right, let's go for 2000. You don't have to hit every point because the efficiency map is generally quite smooth. There's no major efficiency changes. So anywhere where you've got known accurate points, well, you kind of smooth and lower the numbers or raise the numbers around that so that it follows the same general shape as what you see there now. So we've got another 5% out there. And whoops, I'll tab back, 2000, and we are 65. All right, so we can split the difference here. The numbers are quite similar between 60 and 70, so I could just go across here and go times 0.97. All right, and backspace. All right, then keep going. We've got 2.5 here. We can scroll in, and here you can see the lambda is not meeting the aim. All right, so it's a couple of points under, and we've got 5% out. So if I pull 5% out of here, we should be within a few percent. So I'm going to do that. Go back 2,500, 70 kPa. All right, that's there. And so times 0.95. All right, backspace. Keep going. 3,000, pretty much the same result. 3,000, 70 kPa. Across to here. Times 0.95. Backspace. All right, so that's the process. You just move through the different RPM. Let's just quickly keep going. Kind of similar load here at 3.5. So still 70 kPa. All right, but now we're -2, -3%. I'm not even going to be too worried about that. We're scrolling out here, pick it up over here. We can move it over. And look, to be fair, I wouldn't be too worried about this. You can sneak a little bit out all the way to 4,000. It's only 3 or 4%. It's really up to you if you want to correct that. I would do it over a longer period of time. You can check it on our later version of software. This will have auto tune in it, so you won't even need to do this. But kind of the first time we're out, I want to make sure things are certainly within the range of the closed loop, and certainly on the underside, so closed loop always pulling out. So if we ever have a problem, as I say, with the lambda sensor, then it's can go into a open loop mode where it's a little bit richer than normal. Now we've done our first lot of looking at the fuel side efficiency map. If I press F6 and then G and G, we can see our points where we've pulled a little bit of fuel out. Now for, I think virtually, other than the V6, for all the Mercury engines, they generally have this same shape where up to from 0 to 100 kPa, up to there, perhaps 70, 80 kPa, there's a bit of a slope up. This is in general for most engines. This is where the throttle's restricting the engine's ability to flow air, and so the engine's efficiency is lower, so that's why we get that shape. And then once you get to 100 kPa, it's virtually flat. Like the numbers are quite similar. And then as we move to the right, like this, across here, as the engine, the camshafts, the inlet manifolds start to work better, you'll get to your peak torque point. And so it'll make a little bit more air per revolution. So then the fueling numbers are higher, the engine efficiency is higher. And then as you get higher and higher in the RPM, it will slope away. And the more that you move past peak torque, the more it will lose its efficiency and these numbers will decline. So, of course, depending on the fuel you're running, if it's got ethanol in it, every engine's a little bit different. Some of the different models of Mercury have different inlet manifolds, is my understanding. There's always little changes from engine to engine. And so we've got the ability to get that perfect. So here's our corrections. You can see the little dips there. So often I will just go to that dip there, go to the number above, highlight it all by holding down Shift and using the arrow, and then use page down like this, and that's only a few percent. Go below the number, page down, and that's probably good for us. All right, go to the next one, down here, page down. All right, and through to here, page down. All right, trying to maintain that shape. Now, of course, does the engine's efficiency go up like this and then down again? The answer to that is no. So then we're going to fill that in like that. All right. And similarly here, got a data point there, just a little bit here. This is my way I do it anyway. You'll get the idea. And we're just using experience to make these adjustments. Okay. And probably that one there, I would go the whole way, pull that down, and we're pretty close. All right, and there's a tiny, that was that tiny mark we made there. Yes, we could take that, go down a little bit, a couple of clicks, go up to here, a couple of clicks, and then the reality is we'll probably go through here and a couple here, and pretty much fix that side of it. And these changes could easily be because, as I say, where you filled your boat up that particular day, I had a little bit of ethanol in there, and so that will affect the engine's the amount of fuel you use, which affects the shape of the efficiency map, how the lambda reads, etc. All right, so that's our first stage for the fuel side. Time for us to rename that, so let's go File, Save As, and when I'm tuning, I just add a number on. I have P for Peter there, and 8. If someone else is tuning, you can have other people dial in remotely and tune, and you might, put their name on there, S, and 3. And if there's 2 people going backwards and forwards, you just increment your number as you go. All right, go OK to that. And we're ready to test our fuel side. Now we're also checking knock, of course. So let's go back to the software and go across to our knock page. Here, again, up the top, we have our engine speed, manifold pressure, and we've got our 8 knock levels and our knock threshold. So these knock level channels are let's just choose one cylinder, number 1, for example. Cylinder number 1 knock level is the result of 4 different channels called cylinder number 1 A, B, C, and D levels, and each of those 4 levels is a different frequency that we're looking at doing knock analysis on in the ECU. Now we're not going to get into the detail of that, but what you'll be looking at is the final result, which is the loudest of those 4 knock channels, A, B, C, and D. So what we aim to do, our core task here, is simply to make sure that when we're under load, all these knock channels here read approximately the same, so they're even. So the software has some gains or some multipliers that we can change to bring all of these channels to a similar level. And then the second thing for us to do is make sure that the knock threshold, which is the brown channel there, is sitting above those background noise knock channels. And then what the software does, if we have a knock event, it goes over this knock threshold, and then the maths in the background will retard timing on that one cylinder. So up to 4,000, and hey, we're only at 70 kPa. We're not going to be having any problems with knock. What I'd like to do is show you the process of how we look at how even the knock channels are. At this level here, we're not going to be too concerned about balancing them unless they're really a long way out. So if you have a look, we're going to zoom in a bit and vertically zoom, and now we can see a bit more detail. But what we want to do is be zoomed right out before we do the next test. So now I'm going to click on each particular cylinder, and it's going to bring that color to the top of the 8. There's a group of 8 knock channels here, and as I click on each one, you will see it come to the front, and then we'll see them come forward, and if there's one that's really low, then that'll become obvious, and then we can change the gain on that. So let's go all the way down to number 8, because that's not at the front, and we'll start from the bottom. All right, so number 8, you can see I've clicked on that, and if anything, that is, you know, it's got the most gain, it's got the most noise, but it's not really significantly above any of the others. We click up one at a time, and we're looking across. We can see they're reasonably well balanced. We could be fussy here and move them around a little bit, but at this point, at 4,000 revs and only 70 kPa, no boost, we're not too concerned. This isn't where we're going to have knock. So it's not until later when we test at wide open throttle that we're going to look a little more intensely at this. So for now, are these background noise knock levels going over the threshold? No. Is the threshold a reasonable distance away? Yes. Is it excessively away? No. It's about, what's our threshold? 30%, and our knock levels are sort of sitting at around 10, 15. There's very little load on the engine. So everything's kind of sensible. It's just a little check. The reality is you'll probably just do this on the water. It takes you about 10, 20 seconds. Flip to this page on the live screen and you can check this off and keep going. All right, so all that's in order. We're ready to go retest. Let's head out to the water and do the next stage. All right, so heading back out, we've made those few adjustments. Now we'll go back up through those increments just to double check that everything is good there. Just accelerate smoothly, we should be able to check it all. And then we'll go another 1,000 in 2 steps, checking that that's all good. And then in reality for you guys, you can go all the way to the end, and as long as things are in line, you can get to the point where you're through to wide open throttle and everything's all on target. All right, if it's not, stop, correct it in the efficiency map, balance those knock channels. Ultimately, once you're confident the thing will go full throttle, max power, that's where you want to fine tune those knock channels the most. Having them perfectly even at 2,000 or 3,000 is way less important than where it's actually going to do the work for you, which is at full power. All right, so let's go through and do that now, and we'll check back in a sec. Off we go. So here we go. The 4,000. Four and a half. Bit away. Across this choppy bit. $5,000. Five and a half. So you're in a nice big smooth boat. You can obviously do this on the fly if you're on the laptop. Otherwise, yeah, a lot of people won't have the luxury of a nice smooth lake like us. So you go and do your run and then stop, pause the data, have a look through. If everything's all right, you can proceed. All right, so we'll head back to base and have a look and go from there. Let's go. All right, that was a bit more fun. Went a bit quicker. We've got the data here down now. So as before, we're going to have a look at all the different engine speed and manifold pressure intersection points and correct the data. Alright, so head to the tune screen and we can just double click on a section here to expand it. Alright, so we went to 4 grand last time. Okay, so we're going to have a look at each different engine speed and line it up with the manifold pressure point. Of course, if you change the prop for any given engine speed, if you put a bigger prop on, then there'll be more load on the engine, so the manifold pressure will be different. So we've got a nice intersection point here, close to 90 kPa. We're exactly at 4.5. Let's go back to the tune-up. Here we are. Here's our SpeedLab P8. And let's go and have a look. We are 4.5, 90 kPa. By now you guys will be onto it how to do this. And so sometimes if I'm happy with it, I'll still mark it. I won't make a change and I'll just mark that as being good. So I'll just go backspace. I'm good with that. All right, and up we go. 5 grand. I'm okay, but now we're up about 5.5 and we're not on target and we've got 5% trim out. I mean, it's just on target, so we need all of 5% out. In this case at 5.5. We have a look here, right on 5.5, we're at 120 kPa, so 5.5, 120. So 5,500, 120, so we're going to go times 0.95. All right, and backspace. So same thing as before. We're going to move through and go to each location and make changes. Here's our 6,000. Okay, about 130 kPa. And again, we definitely want to take all 5% out because we're only just touching. We're slightly richer than our aim there. So, you know, at least 4% anyway. All right, so go back, 6 grand, 130, 6,000, 130 times 0.96. All right, and you've seen the rest, so you know how to smooth that out, get it ready for our next test. That's that job done. Let's move to the knock. And we've got a bit more going on now. You can see a little bit more the background noise is higher. If you get a knock event, it will go a long way over the threshold, way over 100 for a decent sized knock event. So for now, nothing. And somewhere around here, close to wide open throttle here. And we'll have a look at our balance. So what we're going to do is just go through again and have a look. So there's the purple. You can see it's kind of down a bit. If we're going to adjust that up, zoom out to get it. You can get the shading better if you bring it right out. So if we have a look, click through them again. Red is definitely well above. So 2 is definitely well above 1. 1 is definitely 1 needs to come up. 2 and 3 are pretty similar. 4 probably up a little. 5 is down a bit. 6. So I'm just getting a general feel for it, and then we're going to come back through. So number 8's okay. You probably have to get a piece of paper out here or Alt-Tab like what I'm going to. So 1, I think 1 can come up probably, if you look at it, maybe to 15%. So let's go and have a look to see where to do that. So we're going to go to Workspace, Engine Tuning, Ignition, and Knock. Alright, so here we have our, I'll just stretch it out a little so you can see it better. So each cylinder's gain here is recorded as a parameter, and we can change this gain and move this however we want to make more background noise or less. Alright, so what did we say? Number 1, definitely down, so we're going to add 15% to number 1, so it's 135 times 1.15. There you go. All right, let's go to 2. 2's pretty much the same as 8, so we'll leave that there. So 2 is good. 3 is pretty good. 4 maybe up, maybe 8%. So let's go to cylinder 4 gain. Click over here, times 1.08. 5, definitely up at least 15%, I would think. Cylinder 5 times 1.15. Cylinder 6, yeah, it's pretty close. Cylinder 7, maybe up 8%. 7 times 1.08. And 8, that was right up there. So that's the cylinder balance done. It's something I would keep an eye on once you start doing long, hard runs, you know, at whatever it's going to pull, 6.5, 6,600, then have another review of that. But what concerns me here is we're really quite close to the threshold at this point here. All right, so I can zoom right in with the mouse. If we have a look here, if I click at that point, okay, number 8, I could remove it with the gain. I might do a little bit of both to be fair, so that the number 8's background noise is 39 and the threshold's only 44. So not much more noise on this cylinder, and it's going to be starting to trigger retard, which we don't want to see. All right, so let's lift the threshold 5.7 at 120 kPa. I'll show you how to do that. And we'll take a bit of gain out of number 8 as well, just a smidge, maybe 5%. All right, so times 0.95. So we got a little bit out of number 8, and we're going to go to the knock threshold. So if we come up here to the knock threshold, here it is. So this is engine speed by engine load normalized, which in effect is just manifold pressure. So we are at 5,700 and 120, so we are right around this part here, just above here. So in general, what I would do here, if you look at the graph, I'm just going to highlight here and go up here and go, I don't know, 10, shift plus, okay? And we'll just move that threshold away. Now you get different gain values and background noise knock channels can go up and down with how mechanically noisy the engine is. The ECU filters out most of the mechanical noise, but it doesn't filter all of it. And so if the engine's a little bit, a little bit noisy, well worn, done 1,000 hours, got a loose tappet, that kind of background noise makes its way in and is represented in the knock channels. But the lower the frequency here, the more the background noise will be up. We just want to make sure the knock channels are balanced and the threshold is, a good 30% above the background noise. All right, so that's it for those changes. I'm going to go File, Save As, P9. All right, so that's it for now, and we'll head out to the water and we'll do our next testing, something like boost control.